Hello everyone, I Nikhil welcome you to Vigyan Bharat. Let's discuss the problem of the day for 2nd of September 2022. From today onwards I'll be making some changes. Like first I'm going to discuss a concept and that will going to involve the problems for the day. So today I have taken the subject which I have chosen is differential equations, and in this I'll be discussing this topic of exact differential equation, what we mean by an exact differential equation. And today problems are of MCQ as well as NAT type, that is numerical answer type problems, and multiple choice question, that is 4 options will be there and you have to choose the correct one. So let's discuss quickly what we mean by an exact differential equation. Let's look at the definition first. An equation of the form m of x comma y dx plus n of x comma y dy equals to 0 is said to be exact where this m is a function of x and y, this n is also a function of x and y. Then we say this equation 1 is exact if it satisfy this condition. That is, if we differentiate the function m with respect to the independent variable y, that is the partial derivative of m with respect to y, equals the partial derivative of this function n with respect to x. If you calculate these partial derivatives and if they come out to be equal, then we say the equation 1 is exact. And in the case when it satisfies, the general solution to equation 1 is given by this here. How it is given? You simply have to integrate the function m with respect to the variable x, plus you have to integrate the function n with respect to the variable y. But remember, here there's a condition which you have to be aware, that when you will going to integrate the function n with respect to the variable y, then in that case you're going to consider only those terms which are independent of x, or those terms which does not contain x, and equal to c, where c is some arbitrary constant. So this is the general solution how for an exact differential equation. I hope the definition is clear. Now let's move ahead with the problems of the day for based on exact differential equation. Very interesting problems. Today I have chosen 4 problems. You can easily see one by one. Now in these problems I would like to discuss that particularly the first and second problems are just excised. If you just I have given these simple problems so that you can easily recall the method and you can solve it, although the second is an interesting one. In the third problem you have to manipulate the given equation, because you see in the first and second directly I have an equation of the form m dx plus n dy equals to 0, but in the case of third problem, it is not like that. So you have to manipulate the terms and reduce it to this form. Okay, so try to solve the equation third. And finally the last problem I have marked it with this star over here because it is a very interesting problem. You are given the general solution of this differential equation which is exact. You are given an exact differential equation whose general solution is this, where is given by x square plus y square equal to alpha, where alpha is some real number. Then you have to calculate the value of this. It is asked in some competitive examination to try to solve this problem, each and every problem, and do participate in the Telegram group. Post your solutions over there, or any doubts if you have, you can ask them there. Join the Telegram group. You can find its link in the description of this video as well as the about section of our channel. So try to join the group and feel free to post your doubts if you have any in the not related to this video, but any doubts anywhere if you have, you can post them on our Telegram group. If you are new to our channel, then I would definitely say go through the content of the channel, as well as if you find this video to be useful, then you should like it. And for receiving such content at the earliest, you should subscribe to our channel and press the bell icon for receiving the notifications at the earliest. So thank you so much for watching. That's all for today video. Thank you so much.